A right triangle has one right angle, and we know it's a right angle by the little box inside. An obtuse triangle has only one obtuse angle. Then we broke triangles down by sides. We know that at equilateral sides, all the sides are equal or congruent. We also know that equilateral triangles are always acute. This is a key thing to know when we talk about line of symmetry. That way, if you know that an equilateral triangle, all sides are congruent, we know that an equilateral triangle has 3 lines of symmetry. Then we go on to our isosceles triangle, where there are 2 sides are congruent. We remember that the word isosceles has the word I, and I like to think about it is that we have 2 eyes. So if you think about it as we have 2 eyes, we think about it as 2 sides are congruent. And then a scalene triangle has no congruent sides. From triangles, we moved on to quadrilaterals. Quadrilaterals are shapes that have 4 sides. We need to remember that quadrilaterals equal 360 degrees. Again, we broke it down by their sides, and we broke it down even farther, not just by sides, but by parallel lines. Parallel lines are two lines that go on and on forever in a straight path, but never intersect. So if we go on to our trapezoids only have one pair of parallel sides. Then we have 2 types of trapezoids. We have isosceles trapezoids that have one set of parallel sides but no right angles. Then we have a right trapezoid, which contains the right angles and also a pair of parallel sides. Our irregular quadrilaterals have no parallel lines. And then we go on to our parallelograms. Parallelograms have 2 sets of parallel sides. Now, a parallelogram, what makes it different is that it does have its 2 sets of parallel sides, but it only has 2 sets that are congruent. We break down our parallelograms by 4 right angles, making a rectangle. Again, it has 2 sets of parallel sides, 4 right angles. However, only 2 sets are congruent, and those tick marks let you know that these sets are congruent and these sets are congruent. Then we go on to if it has 4 congruent sides. If it has 4 congruent sides but no right angles, it's a rhombus. If it has 4 congruent sides and 4 right angles, it will be a square. A few more things that we need to know for geometry. Area versus perimeter. And this is something our students really struggled with because they often confuse them. But the way that we discuss it is that you have your rim. So if you have a rim, it is what's on the outside. So if we're trying to figure out the distance around a shape, our formula for quadrilaterals or for perimeter for always is going to be side plus side plus side plus side, depending on how many sides are in the shape. Because they might ask for a perimeter of an octagon or a pentagon, and all they have to do is add up the total number of sides. But for quadrilaterals, we also have length times length times 2 plus width times 2 equals perimeter. So we went ahead and did an example where we did 2 feet plus 8 feet plus 2 feet plus 8 feet to get 20. Area is what our students seem to like better because all it is length times width. However, majority of our students forget to put that little squared unit. And they need to make sure that they put that squared unit to tell us that we're covering everything that is inside. Another big thing the students need to know is there are different types of lines. Again, parallel lines never intersect. They go straight on forever and they never intersect. Perpendicular lines do intersect, but they intersect forming the right angle. Again, we know that because of the little box. Intersecting lines are 2 lines that intersect again, but they do not form right angles. Well, now we need to know about our angles. So we have acute angles that are less than 90 degrees. We have our right angles, which are exactly 90 degrees and have the little box as a reminder. We have our obtuse angles, which are greater than 90 degrees, and then we have a straight angle, which is exactly, and that should be 180 degrees, which is also the same thing as a straight line. So now we have a few word problems that I would like us to go over, and I'm going to show you how to use what we have learned in quarter 3 to help us learn. So the figure below is a rectangle made up of 2 right angles. And my students should be writing that a right triangle or a right angle has 90 degrees. Angle XWZ measures 50 degrees. So I would actually have my students trace over XWZ, and I would have them write in there that that is 55 degrees. But we're looking for what is the measure of angle YWZ. Now, a good thing for us to remember is that our vertex is always this middle one. So if we look, we're looking for YWZ. And again, I would have my kids trace that out and then write a question mark. Well, I need to find that total. Well, if I know that it is a right triangle, then I know that a right triangle measures 90 degrees. And then I would need to subtract 55. Well, 0 can't minus 5. So I'm going to go to my tens column, and I'm going to decompose my 10 or break it down. So I'm going to take a 10. That will leave me with 8 10. And then I'm going to add 10 ones, because 10 ones is the same thing as 1 10. 10 minus 5 is 5. 8 minus 5 is 3. So my answer is 35 degrees. This is a view of a picnic area is shown. The line segments in which line segments in the pictures appear to be parallel lines. My students should know that that is the key information, so we need to circle it. And we know that parallel lines, if we go back to our notes, never intersect. So my students should be drawing over it. They should be drawing, and it should go completely out, so JP and LM. Well, we see that JP and LM will never intersect, so we know that they are parallel. If we continue, we have JP and PM. Well, these lines intersect. If we go KL and LM, those two lines intersect. If we go PN and we go LM, well, if we keep traveling down, we will see that those lines also intersect. So the correct answer should have been A. This is where things get a little confusing, is when we get to these gigantic word problems, and they tend to scare a lot of our students. But if they break it down by using the step-by-step model drawing, things should be a little easier. So Mr. Rhodes needs to purchase fencing to fence his garden. The garden is 20 inches by 15 inches and is in the shape of a rectangle. The fencing is sold in packages that cover 20 inches per package. What is the perimeter of the garden? How many packages of fencing will they need to purchase? So this is a two-step problem. So first we need to figure out the perimeter and then the packaging. So we have our students read the question and then they need to write the statement. So the first statement would be the perimeter of the garden is blank inches. That would be our first thing we are solving. The second thing we are solving is how many packages of fencing will he need to purchase? He will need to purchase blank packages. Now, I know we keep talking about step-by-step model drawing in class. However, with perimeter, I always tell my students that I want them to draw the shape. So we were told that this was going to be a rectangle. And we were told that it's 20 inches by 15 inches. And we learned earlier, if we go back into our notes, when we were talking about area and perimeter, that perimeter is us adding up all the sides. So I would have the students write perimeter equals side plus side plus side plus side, just to keep it fresh in their mind. And then I would go ahead and fill it in. Perimeter equals 20 plus 20 plus 15 plus 15. That would be 40 plus 30. That would be 70. And we already have our unit up here, so that is 70 inches. Now we need to figure out how many packages we are going to purchase. Well, we know we need 70 inches. Now we're going to do our step-by-step model drawing. We know we're looking for our number of packages. Now you can label it with the word packages or with P if you're aware of what you're looking for. We know that one package covers 20 inches. Well, we know we need a total of 70 inches. So, if one package covers 20 inches, we are looking for our total number of packages. We don't know how many packages we're going to have, so we're going to put question mark package. But we do know that question mark package will also cover 20 inches. So, how many packages will we need to get? Well, we have 70 divided by 20. Well, 70 can go into 20 3 times. Because 3 times 20 would equal 60. Well, then we have 10 inches left over. So do we need to buy 3 packages, or do I need to buy another package to cover that 10? And that's a question our students will need to think about. Is it just 3 packages, or do I need to take my remainder and do something with it? Well, in this one, we need to cover a total of 70 inches. Well, 3 packages is only going to cover 60 inches. Well, 60 inches is not enough. So I'm going to need to add a +1 to my quotient to make it 4 packages. If I get 4 packages, that will cover 80 inches. Well, we need 70 inches covered. 80 is greater than 70, so we will need to buy 4 packages. Adriana's swimming pool has 4 sides, none of which are perpendicular. 2 sets measure 17 meters long and 2 sets measure 24. Again, none are perpendicular. What best describes the shape of the pool? Well, this one you really don't need a statement because you're just going to be figuring out the shape. So if I was a student, I know that I'm going to have 24 inches, or 24 meters, excuse me, and 24 meters. Well, I need to remember that none are perpendicular. So if I go back to my math on quadrilaterals, and I'm looking for sides that are not perpendicular. And perpendicular means they're going to intersect at a right angle. Well, perhaps it can be a trapezoid. However, we have to remember that 2 sides are the same length and the other 2 sides are the same length or congruent. So we need to come over here. Again, we know it can't be a square or a rectangle because those make right angles. Therefore, they are perpendicular. So we're stuck with a rhombus or a parallelogram. Where a rhombus has 4 sides that are parallel. Our shape has 2 sides the same length and then 2 other sides that are the same length. So our shape would be a parallelogram. Last problem with geometry. Ms. Dubé wants to build a swimming pool in her backyard. She will need it to be long enough and wide enough to host large pool parties. She requests that the builders make it 60 feet long and 30 feet wide. What will be the area of the pool? Again, we're looking for the area. So the area of her swimming pool is blank feet squared. Now I know she's working with feet because it came in the problem. I know that I'm doing area, so I'm going to need to square my unit. Again, I would not have the kids do a step-by-step model drawing. Instead, I would have them draw the shape. Now, it doesn't really tell us what the shape is, but we know that 2 sides are going to be 30 feet. So those 2 sides are going to be congruent, and the other 2 sides are going to be 60 feet. Again, my picture is not drawn to scale. And so I'm just going to make it easy for me, and I'm just going to make a rectangle. And then I'm going to go area equals length times width. So area equals 60 times 30. Now, I've taught our students to do this in two different ways. When I see that I have zeros on the